All right, guys, here is your 4.2 SOH notes. Now, I know that the 4.2 stuff, the SOH that we're going to deal with is just finding sides, and I believe that these guided notes will also find some angles, which will come in handy if you decide to go for an A in this unit and you want to do 4.8, use SOH to solve real-world problems, or if you're trying to get a B and you want to do 4.6, use SOH to find the measure of the missing angle. I'm actually going to touch on all of those just a little bit here. And first of all, I should probably let you know that when we talk about SOH, really what we're talking about is trigonometry. In trigonometry, in a mathematical sense, is we want to break down these words into their parts, where metry means measurement, and trig means pertaining to triangles. So really, when we talk about trigonometry, we're talking about the measurements of triangles. And when we talk about a ratio, a trigonometric ratio is just a ratio of the lengths of the sides of a right triangle. Okay, so that word there is right. So there are three main trig functions that we deal with right triangles, and they are called the sine, okay, that's pronounced sine, S-I-N-E, pronounced just like S-I-G-H-N. The second one is called cosine, and the last one is called tangent. So as I think about SOH, right, this is the S of SOH, this is the C of SOH, and the T is of the word TOA. So really, as I look at the word SOH, and you'll see this word down here, all right, it's not a real word, it's kind of a word that's made up. But most people that have taken any sort of high school geometry class do know this word as being the way to remember the three trig functions. And this is kind of how I remember them. So is SOH. So I actually write it like this. S with an O over H. And then CAH is CAH. And TOA is TOA. So I remember it kind of by those little visuals there that you see on the left. And what this says is the sine function. Now, we take these trig functions of an angle, and the sine function is defined as the opposite side divided by the hypotenuse. So you will notice here when I say so, S-O-H, that stands for sine opposite over hypotenuse. So if I'm talking about angle A, so here in my picture, here is angle A. The sine of angle A will be the opposite leg. So if I look over here, here is the opposite leg, it is A, over the hypotenuse, and the hypotenuse is easy because it's always across from the right angle. So A over C. So whatever those sides may be, if A is 10 and C is 16, then the sine of A is 10 divided by 16. Right? It's going to be a ratio. It's going to be some sort of a decimal answer. All right. If I want to find angle B instead, all right, here's angle B. The opposite side of angle B is over here. It's actually side B divided by the hypotenuse, which is still C. So the sine of B is B over C, whereas the sine of A is A over C. And you're going to start noticing here, as I think about cosine, again, I'll move that down because the hypotenuse is still C. Now cosine is A over H. All right, well, the H, we know that word is hypotenuse. But the word A means it is the adjacent leg. So the leg that is touching the angle, the word adjacent, we see that again. So if I look for the cosine of angle A, so here is angle A, Which leg is touching angle A? Well, it's this one right here. So that is leg B divided by the hypotenuse, which is still C. All right. And if I want to find the cosine of B, here's angle B. The adjacent leg is right over here. It's the one that's touching it. That's A divided by the hypotenuse, which is C. And if I want to find the tangent, again, I'll drop that down because the hypotenuse is still C. So the tangent is O over A. Well, the O stands for opposite leg. And the A stands for the adjacent leg. So the ratio here, if I want to find the tangent of angle A, here's angle A. It is the opposite leg, which is A, divided by the adjacent leg, which is B. And I don't even need the hypotenuse at all in this one. If I'm going to be thinking about angle B, the tangent of angle B is the opposite leg, which is B, divided by the adjacent leg, which in this case is A. So it's going to be B divided by A. Now I know this feels very arbitrary right now, but just kind of letting the notes unfold with you. And when you start taking a look at some example problems, it makes it a little bit easier to recognize. The big thing that I need you to take from this top section is that word SOH, TOA, right, where S is O over H, C is A over H, and T is O over A. All right, so let me take you down to the bottom of this page. All right, let me show you how this actually works with a real triangle. Here are some rules that you can kind of go by. Right? The trig order is always, always, always start with your angle. Find your angle first. Then identify the sides as opposite, adjacent, and hypotenuse. So I will actually use the letters O, A, and H. And then if you're just finding the sine, cosine, or tangent ratio, just use SOH, TOA and write it as a fraction. Right? Write the ratio down. If you're finding a missing side or an angle, like examples 2 and 3, you're going to use SOH, TOA to write out an equation, then solve the equation. So let's take a look at example number 1. It says R is 16 and S is 30. So R over here is 16, S is 30, and T is 34. And it wants to find the sine, cosine, and tangent for different angles. So, in part A, it wants us to identify angle R. So here is my angle R. So this 16 over here is opposite of angle R. The other leg that is touching it is the adjacent, and across from the right angle is the hypotenuse. So the first thing I want to do is I want to identify the opposite, adjacent, and the hypotenuse. So when I want to find the sine of R, sine is SOH, TOA. So O over H. So 16 over 34. And I could reduce that fraction if I want to, or I could turn it into a decimal if I wanted to. Right, I'm just going to leave it as 16 over 34. The cosine of R, so CAH, that's CAH. So A over H, the adjacent side, which is 30, over H, the hypotenuse, which is 34. And again, I could reduce that fraction if I wanted to, or turn it into a decimal if I wanted to. And the tangent of angle R, in SOH, TOA, that's O over A. So O is 16, it's the opposite. A is 30, it is the adjacent. And again, if I wanted to simplify that, I could simplify that. Now, how does this change if I say identify angle H? So let me pull some of this stuff out of the middle. All right, so angle S. Now, angle S is the side that I care about. Well, this changes my O and my H, or my O and my A, because now across from angle S on the opposite side is 30. So this is no longer A. This is O. The leg that is touching angle S is over here. That is my adjacent. And the hypotenuse does not change. It's still the hypotenuse. So now to find these ratios, the sine of angle S, sine is opposite over hypotenuse. So O is 30 over H, which is 34. The cosine of angle S is adjacent over hypotenuse, so the adjacent side is 16 and the hypotenuse is 34. The tangent of angle S is the opposite, 30, over the adjacent, which is 16. So to find those ratios, it's just a matter of following along with that word, SOH. You can see it right here, SOH. See it right here, SOH. Right? If you want to find the sine, you need to take the opposite side and divide it by the hypotenuse. Whether it's angle R or angle S, the first thing I do is I identify my angle and I label my sides as O, A, and H. All right, let's turn it over here and go to questions, examples 2 and 3. So example 2, this is really what I want you to be able to do. So when we're talking about this learning target number 2, this is the meat and potatoes of it. This is what I really want you to be able to do. So let's identify the angle in part A. It's 54 degrees. So the legs straight across, this one is opposite. The other leg that it touches is adjacent. And across from 90 is the hypotenuse. So in this case, I'm looking at my variables. Okay, so I have my variable, and I don't want to use the word variable, I guess. Those are the pieces of information that I have. All right, my angle, and then I know the opposite side is W, and I know the hypotenuse is 17. So I'm going to actually get rid of this A, because I don't know anything about the adjacent side, and I don't need to. I'm going to think about the word SOH. And I want to know which one of these three deals with the letters H and O, since these are the only two letters that I'm dealing with. And that means I have to use sine. It deals with H and O. The other ones are A and H or O and A. So in this case, I'm going to do the sine of the angle. Well, now I know that angle, the sine of 54 degrees, is going to equal the opposite side, W, divided by the hypotenuse, which is 17. Well, now if you think back to solving this algebraically, the right side of your equation is W divided by 17. So I'm going to multiply both sides by 17. That will help these cancel. And I'll just be left with W on the right. And on the left, I have to do 17 times the sine of 54 degrees. Well, the good news is your calculator will do this. So let me jump over here. 17 times, here's the sine, S-I-N, of 54 degrees. Check that. 54 degrees. All right, now, before I do anything else, I do need to make sure that my calculator is set up into degree mode, since that 54 is a measurement in degrees. And I do that by hitting in that top row the word mode. And as I look down, I just need to make sure that I am in degree mode. And actually, my calculator is not. If you look down here, it is right now highlighted in radian mode. So I'm going to go over here to degree mode. Alright, that's better. Now I'm in degree mode, so I'll quit that. So 17 times the sine of 54 degrees is 13.75. So 13.75. This over here is 13.75. And that should make sense because we know the hypotenuse has to be the longest side. So since W is a leg and 17 is the hypotenuse, my answer should have been less than 17, which it was. All right, for letter B, all right, example B, here's my angle. So the leg that's on the opposite side is the opposite. The leg that it's touching is the adjacent. And across from 90 is the hypotenuse. Well, as I take a look, just like I did in that first problem, these are the three pieces of information that I have. They deal with A and H, so the O is not being used. So, of my three trig functions, I need the one that has an A and an H in it, and that is cosine. So the cosine of the angle, which is 33 degrees, is equal to A, 4.5, over H, which is W. When I see problems like this where I have to divide both sides by W, you can actually get away with multiplying both sides by that denominator, multiply both sides by W. It makes the W's cancel on the right. And on the left, I will have W times the cosine of 33. And that has to equal 4.5. And then I need to divide both sides by the cosine of 33. That will cancel this side, and that will leave me with my W. So I need to do 4.5 divided by the cosine of 33. So 4.5 divided by the cosine of 33. So 4.5 divided by the cosine of 33. And again, my calculator is still in degrees. So 5.37 if I were to round it. 5.37. And if I think about 5.37 as being my hypotenuse, it should be longer than the leg, and it is. You're going to hear me say a lot of times when I see problems like this, for years I always told people when you have that W underneath, you can do what I call the old switcheroo, which just means take the cosine of 33. So if I have this, the cosine of something, like 33, and it equals 4.5 over the variable. If my variable was in that denominator like that, I can actually just switch. I can just switch these two things. And I called it the old switcheroo because it was easy to remember. So that makes the W go to the right side. The 4.5 doesn't switch, but the cosine of 33 switches with W. And as you can tell, that is right there. That is the exact same thing that I end up getting. So when you see that variable in the denominator like that, feel free to just switch the variable in the left side and just switch it. Make sure that your fraction numerator stays the same and you'll be just fine. All right. Well, this is going to bring us to example number 3. And this is still TOA, but this is actually 4.6. If you are looking to get a B, this is section 4.6. This is using TOA to find a missing angle. And that means that you have to use what's called the inverse. And the inverse in our calculator looks like this: sine with a -1, or cosine with a -1, or tangent with a -1. So if you're just trying to get this 4.2 stuff, you can actually jump ahead a little bit in the video until this example's over. But for those of you that want to hang around and do this one, by all means. This just says let's find x. So here's my angle, it is x. So I'm going to identify my sides. 6 is on the opposite side, and 10 is the hypotenuse. So this means I'm using the sine function, because in SOH, TOA, opposite and hypotenuse are used. So I will do the sine of x will equal the opposite 6 over the hypotenuse 10. Well, the inverse just says if I want to get the x away from sine. Now, understand that inverse of addition is subtraction, and the inverse of multiplication is division, and the inverse of squaring is square rooting. If I want to do the inverse of a trig function, then really what I'd use is I just use this thing right here. This is called sine inverse. So if I sine inverse the sine of x, I'll get x. And if I do the sine inverse of the other side, I will get a decimal. And I need my calculator for this. So I have to do the inverse sine of 6 over 10. So what's nice about these calculators, if you look above the button that says sine, you see sine with a -1. So I'll hit second sine, and there's my inverse sine of 6 over 10. And I just type the fraction right in there. And this will give me the angle of about 36.9, roughly. About 36.9 degrees. So that means angle x is about 36.9 degrees. So this one right here, 36.9 degrees. And if you wanted to find angle z, now I know x. I know that angle y is 90. So I could find z by just doing 180 minus 90 minus 36.9. All right. For example 3, part B, it says again, find angle x. So there's angle x. 20 is the hypotenuse. 15 is the adjacent side. So if I want to find angle x, adjacent and hypotenuse is the trig function for cosine. So the cosine of angle x is equal to the adjacent side, 15, divided by the hypotenuse, which is 20. If I have to get rid of cosine, I will use cosine inverse. So x equals the cosine inverse of 15 over 20. Well, I'll be going to my calculator again. The inverse cosine of 15 over 20. So inverse cosine, so second cosine, there's inverse cosine. 15 divided by 20, 15 over 20. And this angle is about 41.4 degrees. So this is about 41.4 degrees. And again, if I wanted to find the measure of angle A this time, I could do 180 minus 41.4 minus 90, and that would leave me with angle A. You will see problems like that every now and then as well. All right, as you go to the last page, this is a check what you've learned. So this is a real good time to pause this video and attempt both problems. If you're doing the 4.2 stuff, actually you'll want to attempt problem A, and if you're trying the 4.6 things, you'll want to try problem B. So go ahead and do that now. All right. As I take a look at problem A, my angle is 39 degrees. X is on the opposite leg. 15 is the adjacent leg. So I do not use the hypotenuse here. So O and A in the SOH TOA is tangent. So the tangent of the angle, 39 degrees, is equal to the opposite over the adjacent. So x over 15. Well, to mathematically solve for x, I have to multiply both sides by 15. So that means this side is 15 times the tangent of 39. 15 times the tangent of 39. 15 times the tangent of 39. It's 12.1. And that is an approximate. Since I rounded it, that is an approximate. All right, for those of you that are doing the 4.6 stuff, here's one on where I have to find the angle. So my angle, the opposite side I don't know. The adjacent side is 27 and the hypotenuse is 32. So A and H, that means I'm using the cosine function. So the cosine of the angle, which is x, is equal to A over H. So 27 over 32. Now to solve for x, I have to get rid of cosine. So I get rid of cosine by doing the cosine inverse. And my fraction in there is 27 over 32. So cosine inverse of 27 over 32. So second cosine, 27 over 32. This will give me about 32.5 degrees. This is about 32.5 degrees. And again, if I needed to find the other one, I would use the fact that triangles add up to 180 degrees. That is it for actually 4.2 and / kind of 4.6 guided notes.